Hi guys, welcome back to YouTube channel Chemistry Live UGPG. So let's discuss the MO diagram of N2, O2, NO and CO and their ions. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus for Core 1 paper Unit 4 Chemical Bonding. So let's discuss the molecular orbital diagram of N2, O2, CO and NO and their ions. So nitrogen we know the atomic number 7. So the valence shell electronic configuration is 2s2, 2px1, 2py1 and 2pz1. So 5 electrons in the valence shell. So similarly for N2 molecule total 2 into 5, so 10 electrons will be in the MO. So here is the MO configuration of N2. So sigma 2s2, sigma star 2s2, then pi x bonding 2, pi y bonding 2 and sigma z bonding 2. So which is in accordance with very high bond energy, that is having 225 kilocalorie per mole. So if you find the bond order, so this is in accordance with the bond order. So bond order is 1 by 2 whole into number of bonding electrons minus number of antibonding electrons. So that is equal found to be 3. So that means it contains 1 sigma bond and 2 pi bond. So that's why the bond energy is 225 kilocalorie per mole, very high energy. So here is the MO configuration and MO diagram for N2 molecule. So 5 electrons in the valence shell, so total 10 electrons in N2. So the MO configuration is sigma 2s2, sigma star 2s2, then pi x bonding 2, pi y bonding 2 and sigma z bonding 2. So here is the energy profile. So 2s orbital of one nitrogen atom and here 2s orbital of another nitrogen atom. And 2s orbital contains 2 electrons, so total 4 electrons. So when these 2s orbital interact, one will give rise to bonding and another will give rise to antibonding. So 2 electron will go to bonding and the other 2 electron will go to antibonding. Similarly, 2p orbital of one nitrogen atom contains 3 electrons and here another nitrogen atom contains 3 electrons, total 6 electrons. So these 6 electron will go to the 2 of them will go to pi x bonding, then another 2 will go to pi y bonding and the next 2 will go to sigma z bonding. So these antibonding orbitals remain vacant. So bond order is found to be 1 by 2 whole into number of bonding electrons minus number of antibonding electrons. So bonding here 2 and here 6, so total 8 and number of antibonding here is 2. So that's why 8 minus 2, so that is 6 by 2, that is 3. So bond order is found to be 3, so 1 sigma bond and other will be 2 pi bonds. So similarly N2 plus ion, so N2 plus ion means 1 electron will be lost here. So here it will be 5. So here 1 by 2 whole into 7 minus 2. So that will be equal to 2.5. Similarly N2 minus ion. So 1 electron will be added. So another electron will be in the antibonding orbital. So the number of antibonding electron will be 3. So 1 by 2 whole into 8 minus 3, that is 2.5. So now let's discuss the MO diagram of O2 molecule. So O2 has 6 valence electrons. So in O2, so oxygen atom has 6 valence electrons. So O2 molecule have 12 electrons. So here is the MO configuration. So sigma 2s2, sigma star 2s2, sigma z2, then pi x2 and pi y2, and then pi x star 1 and pi y star 1 and sigma z star 0. So these are antibonding MOs. So bond order will be 1 by 2 into 8 minus 4, that is found to be 2. So 1 sigma bond and another is pi bond. And bond dissociation energy is found to be 118 kilocalorie per mole. And it is paramagnetic due to the presence of a 2 unpaired electron in the pi x star and pi y star antibonding orbital. So here is the MO diagram. So here 1, 2s orbital of one oxygen atom, and here another 2s orbital of another oxygen atom. So when they interact, one will give rise to bonding, and this is antibonding MO. So 4 electrons in O2 molecule of 2s orbital, so 2 of them will go to bonding and the other 2 will go to antibonding. Similarly, in 2p orbital, it has 4 electrons, and here another oxygen atom has 4 electrons, so total 8 electrons. So 2 of them will go to sigma z orbital, and the other 4 will go to pi x and pi y orbital, and another 2 electron will go to pi x star antibonding orbital and pi y star antibonding orbital. So your bond order is 1 by 2 whole into number of bonding orbitals, bonding number of electron in bonding orbitals. So 2 here and 6 here. So total 8. And number of antibonding electron is 2 and here 2. So total 4. So the bond order is found to be 2.0. So we have O2 molecule 1 sigma bond and another is pi bond. Similarly for O2 plus molecule, so 1 electron will be lost from here. So the number of antibonding electrons reduces to 3. So here 1 by 2 into 8 minus 3, that is 2.5. Similarly O2 minus 1 electron extra electron will be added to the antibonding MO. So here number of antibonding electron increases to 2 plus 3, 5. So 8 minus 5 by 2, that is 1.5. Now let's discuss the MO diagram of a NO molecule, nitric oxide. So nitrogen, we know the valence shell configuration is 2s2, 2px1, 2py1 and 2pz1. And oxygen has valence electron is 2s2, 2px2, 2py1 and 2pz1. So in total the NO molecule will contain 5 plus 6. So that is 11 valence electrons. And here is the MO configuration of a NO molecule. So sigma 2s bonding to sigma star 2s2 2 electron, then pi x bonding 2 and pi y bonding 2, then sigma z bonding 2, and pi x star antibonding has 1 electron and pi y star has 0 electron and sigma z star has 0 electron. So the bond order is found to be 1 by 2 whole into 8 minus 3. So that is found to be 2.5. So this explains the paramagnetic nature of a nitric oxide molecule. So similarly for NO plus molecule, it is found to be 1 by 2 whole into 8 minus 2. So that is 3.0. So here this is the MO diagram for NO molecule. So here since the electronegativity of oxygen is more than nitrogen, so this will be of a lower energy and nitrogen will be having higher energy. So similarly you can see this is just above this line 2p orbital. So here is the 2s orbital of nitrogen and 2s orbital of oxygen. So two of them two electron will go to bonding and the other two will go to antibonding. Similarly, nitrogen has 3 electrons and oxygen 2p orbital has 4 electrons. So these 7 electrons will be distributed as follows. Pi x orbital bonding will go to 2 electron, pi y bonding has 2 electron, and sigma z has 2 electron, and only remaining 1 electron goes to pi x antibonding, that is 1 electron. So if you calculate the bond order, 1 by 2 whole into number of electrons in bonding MO minus number of electron in antibonding. So bonding is 2 plus 6, 8, and antibonding is 2 plus 1, 3. So your bond order is 2.5. Similarly for NO plus molecule, so 1 electron will be lost. So the number of antibonding electron decreases. So only 2. So 8 minus 2, that is 3 divided by 2. So it is 3. And for NO minus molecule, another electron will be added to the antibonding orbital pi y star. So here the number of antibonding electron increases to 4. So the bond order is 1 by 2 whole into 8 minus 4, that is 2. So let's discuss the MO diagram of a CO, carbon monoxide. So this is a heteroatomic molecule, so MOs are not symmetric. So the atom with a higher electronegativity value will be lower in energy. So carbon valence shell configuration is 2s2, 2px1, 2py and 2pz1. So we have only 4 valence electrons. And oxygen has 2s2, 2px2, 2py1 and 2pz1. So here we have 6. So 4 plus 6, total 10 valence electrons in CO molecule, which is isoelectronic with N2 molecule. And here is the MO configuration. Sigma 2s bonding to, sigma star 2s antibonding to, then pi x bonding and pi y bonding, each has 2 electron. Then sigma z bonding has 2 electron, and these antibonding orbitals remain vacant. So here is the MO diagram. So this is the 2s orbital of one carbon, and this is the 2s orbital of oxygen. So this is having lower in energy with respect to carbon since electronegativity is high. So when they interact, so it will form bonding and antibonding MO. So 2 electron will go to bonding and other 2 electron will go to antibonding. Similarly, carbon has 2 electron in 2p orbital, and here 4 electron in 2p orbital of oxygen. So total 6 electrons. So these 6 electrons are distributed to pi x bonding orbital, pi y bonding orbital and sigma z bonding orbital. So in total the bonding orbitals is 2 plus 6, 8, and antibonding orbitals are antibond number of electrons in antibonding orbital is 2. So bond order is 1 by 2 whole into 8 minus 2, that is 3. So in CO molecule we have 1 sigma bond and 2 pi bond. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistrylivegpg.com. For class 11th and 12th, this is the channel Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.